Hello everyone, we're here today to discuss about telecommunications, and for that we have Professor Muriel Médard, NEC professor at MIT. She's an expert in telecommunications and will talk to us and teach us about these topics. So considering your vast expertise in this field, what is your idea? How do you imagine the future of telecommunications?
So thank you, Anna, first of all, for inviting me. It's a pleasure to have this chat with you. I think we're in a very interesting point right now in telecommunications. To some extent, it's really sort of the merging of what have been somewhat separate types of industries coming together. On the one hand, the industries which are generally associated with the telephone companies, a lot of infrastructure, very reliable, a lot of penetration and distribution of services to everybody. On the other hand, communications that were born more from local area networks, Wi-Fi and systems which we generally associated with either being in the enterprise or in the home, which are reaching out at the same time as they are becoming more and more integrated with cloud services. So what we're seeing, I think, right now is really a merging of these two different types of heritages, if you will, with communications companies more and more going towards services, and at the same time companies that were more associated with computing or enterprise networking getting more and more into domains which were generally considered to be really the purview of, let's say, telecommunications company coming from the telephone origins. So that's a very, very interesting, very exciting time to be active. I should add also that some of the types of services which we thought would be standalone services, such as satellite, are also being merged into this new, much more integrated communications a type of landscape. And of course, the rise of Internet of Things, of a very, very diverse, very heterogeneous set of communications requirements is really creating a confusing but exciting landscape.
So, would you say that these diverse type of communication has enabled, for instance, the evolution of smart cities and smart devices and the densification of such devices within cities, or do you think that's not applicable?
I think it's definitely on its way to enabling that. I think the requirements that are being, in effect, pushed onto networks do come a lot from dense urban areas. It can be requirements such as just the number of users. It can be, of course, more and more requirements from the fact that you have instrumented more and more elements, whether it go from cars, which are becoming more and more increasingly instrumented, whether it be devices in the home, whether it be devices in businesses. So that sort of increase of instrumentation is, of course, creating increased demands on networks, and that increase in instrumentation also comes with heterogeneity that I mentioned before, because you're seeing not just more demand, but also demand in different parts of the network. We already see that with 5G.
Is that challenging connectivity-wise?
So it is challenging connectivity-wise. It's challenging both in terms of the amount of demand and also the types of demand. We already see this in 5G, that you're seeing more and more different types of parts of the spectrum being called upon. So you have, of course, say traditional parts of the spectrum, such as around 2.5 gigahertz. In Europe and in some parts of Asia, that was already around 3 gigahertz. You're seeing parts of the spectrum at much higher frequencies, often called millimeter waves, say 28 gigahertz or thereabouts. And you're also seeing much lower parts of the spectrum being used. At the same time, there's an increased demand to be able to integrate together telephony-oriented frequencies with frequencies that were reserved for services such as Wi-Fi. So there's a demand both for the amount, but also for a diversity of demand.
You mentioned millimeter waves. I know for a fact that it's one of your topics of research, millimeter wave backhaul, is that?
And that's definitely one of the areas that I work in, and in particular with Ubiwhere.
Yes. So we would like to know what you think if millimeter wave backhaul will be easy to implement and to bring to the market, or not, if you think it's easy or not, and if it is, or if you have an idea on how to bring it to the market, if it will be well accepted or easily accepted, and if companies, in particularly enterprises, will be able to employ the technology, in very different verticals, as you were mentioning in the beginning.
So I think that one of the great things about millimeter wave is just how much spectrum is available at those frequencies, right? And that's really one of the most enticing, attractive aspects of that technology. There are challenges, however, and particularly challenges around reliability. So you have abundant resources, but these resources have a lot of variability. So I think that in order for millimeter wave to become truly integrated into an infrastructure play, what we need is to provide mechanisms for better reliability. That's very much the topic of the project through MIT Portugal that we're working on with Ubiwhere, along with several other collaborators here in Coimbra and Aveiro and Porto. And I think that with the right level of robustness and the right level of reliability, it's a very, very attractive technology. You were mentioning backhaul. Providing backhaul through wired systems is very expensive. It's very expensive in terms of infrastructure. It's also very disruptive, in particular in cities. If you look, for instance, in cities such as Aveiro, where we are right now, but also Porto, where we're close, trying to install in an old city and a densely populated city a whole new infrastructure can really be very, very disruptive. If instead you can have a very light touch deployment with smart urban furniture, that's much more attractive. But I think the reliability aspect is really key.
Okay, thank you. So you'd say that if we think about edge computing, energy, privacy-preserving continuum, or even federated learning, we could use millimeter wave backhaul in these type of use cases, we could employ the technology in these areas, or is it not employable?
I think, again, with the correct level of reliability, it's extremely employable. One of the difficulties at the edge, you mentioned particular edge computing, is that, the edge is huge. It's a bit like the skin. The skin is very thin, but it's a huge organ because of, just the sheer distance it has to cover. It's the same thing with the edge. The edge may not require necessarily in any particular spot a lot of, it requires coverage. It may not require very complicated coverage, but it requires it everywhere. And so having this sort of very lightweight, as I said, deployment is quite attractive. The issue of security that you brought up is, I think, quite interesting. There's a lot of interest, of course, in securing higher frequencies. We're doing some work right now, which is sponsored by the National Science Foundation, along with Rice University, Brown University, and also Clemson University, and Technion, actually. We're doing some work in looking at using the physical propagation of high frequencies, even above millimeter wave, in order to provide a very secure connectivity by actively making use of the fact that you have strong zeros, strong areas of non-connectivity. So strong, oddly enough, what is sometimes a challenge in these higher frequencies can be, with the right twist, turned into a very effective, quite powerful way of providing security.
Perfect. I'd like to thank you for this brief conversation and for explaining to all of us these important topics within the area, the field of telecommunications, and for also working with us in suiting the future for new technologies.
It's my privilege to be working with you guys. Thank you.